Does this value belong, or is it an outlier? One measurement looks suspiciously different. Dixon's Q-test, a quick way to detect outliers. Lab experiment. A chemist measures the same sample 5 times. 4 readings cluster together, and then there's 2.9. That looks suspicious. But is it really an outlier? How Dixon's Q-test works. First, sort the data from smallest to largest. The suspect sits right at the end. Step 2. Find the gap and range. The gap, the distance between the suspect and its nearest neighbor. 2.9 minus 1.5, that's 1.4. The range is the total spread. 2.9 minus 1.2, that's 1.7. The Q statistic. Q is simply gap divided by range. How big is the gap relative to the total spread? Plug in our numbers. 1.4 divided by 1.7. Q equals 0.824. The gap takes up 82% of the total range. That's huge. Now compare Q to the critical value. For 5 measurements at 95% confidence, the critical value is 0.710. 0.824 is greater than 0.710. It's an outlier. We can remove it. So what does this mean in practice? 2.9 is statistically too far from the cluster to be random chance. Was it a measurement error? Equipment issue? Always investigate first. Then decide, remove it, or keep it if it's a real signal. Don't just blindly remove outliers. Always ask why it happened first. And remember, remove only one at a time, then retest. When to use Dixon's Q-test. Small samples, 3 to 30 observations. 1 suspect value. No software needed. For larger samples, use Grubbs test instead. Run your own outlier test on MetricGate.